Okay, so your task was to figure out and draw on these pictures what the force vector was going to be. So, and use the right-hand rule to do it. Well, now, on number 1, oh dear, you have to take your right hand and put it in the direction of the velocity vector. In this case, it's straight down. Now, so I'm pointing my hand down. Let me kind of do it off to the side here. So my hand is down. Now I have to curl my fingers towards the direction of the magnetic field, in which case is to the right. So I do this, and so my thumb is pointed down. So this is going to be, is that what you got? Okay.
Yeah, like, is there a little bit of room for interpretation when it comes to drawing vectors? Because like two orthogonal vectors, if they're in the same plane, it's gonna be, it could be like any of these create the same orthogonal vector. So there's room for variance.
A little bit. Okay, now here we go. This is a little bit easier to do. I don't have to be quite so acrobatic about it. The velocity is, I'll cheat a little bit. I can move my paper. All right. The velocity is this way, so I take my right hand, put it in the direction of the velocity, and then fold my fingers down, and so it's going to be off like this. Now, here's the deal. Here's what's nice. Okay, quiet please. The force vector is always perpendicular to the velocity vector, and it's perpendicular to the magnetic field vector. The force is always perpendicular to the velocity and magnetic field vectors. I mean, that's what a cross product gives you. Okay? And so keep that in mind when you're drawing a picture of it. You know, it's not going to be like this. It's going to be perpendicular to the velocity vector. Same thing is true here. Here the velocity vector is down, but the magnetic field now is up, so I got to fold my right fingers up, and my thumb is pointing in that direction. So the force will be like that. And it will be perpendicular to this. Now this one right here, well, it's kind of a trick problem because, well, you put your fingers here and then you curled, wait a minute, what, no, what's the angle between the velocity vector and the magnetic field vector? 180. And so if you want to use the, you know, F equals QVB sine phi, well, if the angle is 180 degrees, the sine of 180 degrees is 0. In other words, if the velocity vector of the charged particle is parallel to the magnetic field vector, there's no force on it. No force on it at all. Okay? So that's the answer to those problems. Oh, so here we would say F equals 0. Okay? There's nothing to it. It has no direction or anything. It's nothing. You got nothing.